Welcome to my channel, Statistics for Applied Linguistics. Again, I'm Dr. Marnie Menegra, and in this video, we are going to look at how to write your research questions and hypothesis statement, or your hypotheses. Now, in a previous video, we discussed the cycle of research, and of course, this is circular, it is not linear, and we looked at the observation, which is putting together your background information. Today, we are going to focus on the induction. So the observation, again, is the creation of the ideas of the research hypothesis based on information patterns. So once we have that information, we write our research questions and our hypotheses, which is the induction phase. The deductions, testing, and evaluation we will discuss in other videos. So first, let's look at the research question, because the research question and the hypothesis statement are not the same thing. The research question is a general question, or you may have several, and you're looking to find the answer to this. This should state your objective, but it does not explain how you're going to test the participants or do the testing in the study to find the answer. So this is more your objective. And an example would be, does allowing students to use Google Translate in a foreign language classroom increase student talk time? Or will students feel more comfortable in a foreign language classroom if they are allowed to use Google Translate? Notice here, these are general questions from this. I have no idea from the question, if I'm reading this, how they're planning on doing this. So these are the objectives. The hypothesis statement, on the other hand, a statistical hypothesis is a statement about a parameter of a population we are interested in. A statistical hypothesis begins with two hypothesis statements and is written mathematically. Now, sometimes in research articles, you're going to see the research questions. You don't always see the hypothesis statements, but a good researcher always states their hypothesis. And so for your thesis, you should have the hypothesis statements. The null hypothesis states there's no significant difference between the specified populations. So if I'm comparing a control group to an experimental group in a series of testing, I'm going to say that after the procedure, there's no difference between these two groups in my null hypothesis statement. So here's an example. There's no difference in student talk time between the experimental and the control group when Google Translate is introduced. The other statement is our alternative hypothesis. This states there is a difference between the specified populations. So an example, there is a difference in student talk time between the experimental group and the control group when Google Translate is introduced. Now, from these statements, I can figure out which test I need to use. So the research hypothesis is used in social sciences, and this statement is written in words. The hypothesis explains the relationship constructs and variables. So you need to state your hypothesis to determine which test you will use. And if you rephrase the hypothesis statement slightly, it can change the test. Now, this has happened with one of my students. A few years ago, I didn't teach the research methods class. And so she had gone to her instructor for that class and asked a question. And when she asked that question, she got a response of which test she should use. But then she came to me and changed her hypothesis statement, and I gave her a different answer. So then she was frustrated because two professors gave her different responses as to which type of testing. And once I asked more questions, I realized that she had asked the other professor something slightly different. So you do have to be careful if you're talking about what you're testing with other people, or you're asking for advice on which test to use, that you don't change the wording of your hypothesis statement. Also, the variable of interest will control the hypothesis. So here's some examples, and there's a website link right on this page here of where I got these examples from. So the research question, does daily use of social media affect the attention span of children under 16? For this, the null hypothesis, there is no relationship between social media and the attention span of children under 16, where the alternative hypothesis, there is a negative correlation between social media use and attention span in children under 16. So here we can see we're looking for a relationship, and this is going to be a correlation. Another one, a research question, are women more likely to go vegan? Now, of course, we're going to ask this question based on the background information. Maybe other studies have suggested that this might be true. So the null hypothesis, there is no relationship between gender and the choice to go vegan, where the alternative hypothesis, women are more likely to go vegan. We don't just make these hypothesis statements and research questions. We don't create them out of thin air. This has to be based on other studies and other background information. So there has to be a reason to test this, and there has to be a reason to ask this question. So here's some examples of hypothesis statements and how it can determine the statistical test. So the first one, there's a relationship between the height of students and the weight. And here we're looking at a relationship. We're not looking at an interaction effect. So for this, it could be a correlation. And there's different types of correlations, which we'll look at in another video. Preschoolers at the age of 2 and 4 years can combine lexical morphemes and form novel blends and compounds. Here, we're not comparing the 2 and 4-year-olds against each other. We are just looking for the frequency of the compounding and blending of lexical morphemes. So we're looking to see when these children are learning to do this. In this case, we're going to use a chi-square goodness of fit. Another example, there will be a difference in the performance of students from pre-test to post-test. So this is comparing two groups or one group with two tests. So we've got the exact same students doing two different tests, and we're going to pair them. And I'm going to just cover exactly which t-test to use again in another video. This is a paired samples t-test. There will be a difference in the performance of students from two classes on a standardized test. So we don't have the exact same number of students. The students are completely different in this case. There's only one test. And so for this one, we're going to use a t-test, which is an independent samples t-test. Now, let's say we have two groups. We've got a control group and an experimental group, and they're doing a pre-test and a post-test. So there will be a difference in the performance of the students from pre-test to post-test comparing two or more groups. Now, all of the students or all of the participants in the study have gone through all of the conditions. So the measures have been repeated for all participants. This is a repeated measures ANOVA. And the last one is the amount of time that students study and their location will influence their overall test scores. So we've got a test, but we've got variables of interest that are the amount of time of study and the geographical location. So in this case, we're going to look at an ANOVA. In other videos, I'm going to walk through exactly what these tests are, so you don't really need to worry about that for this video. This is just an example of how the hypothesis statement tells you which test you're using. So interpreting the results of a hypothesis. Now, we've done the background information, we've created our hypothesis statements, we've tested the hypothesis, run the data through the statistical tests. Now we're going to find out whether the results support the alternative hypothesis or the null hypothesis. So if we get a p-value less than 0.05, the prediction is confirmed. The hypothesis is provisionally supported. It is not proven. So you are not proving anything because the confirmation is never conclusive. The hypothesis is provisionally supported. No scientific statement can ever be fully proven. Now, if the prediction is disconfirmed, this means your p-value is greater than 0.05. The hypothesis is not automatically rejected. The hypothesis is adjusted. So once we reject the hypothesis, we need to find a plausible explanation for the results. If there are plausible explanations for the negative results, we preserve the hypothesis. Otherwise, we may adjust the hypothesis. So how this works, if we go back to that cycle of research, if the alternative hypothesis is disconfirmed, then what that tells us is that maybe we need to adjust some of the things that we've done in the study and test it again. So again, the research, the cycle of research, it is circular, it is not linear. Okay, so this actually concludes this video for today on interpreting the results of, on writing research questions and hypothesis statements. Thank you so much for watching this video, and I look forward to seeing you in the next video.